Hey there! Welcome to our YouTube page, which is all about edge computing. From IoT to AI, we've got the latest tech updates you will want to take advantage of. Make sure to like and subscribe to stay up to date on all the latest breakthroughs and join the edge computing revolution. The role of edge computing in the Internet of Things. Edge computing plays a critical role in the Internet of Things, or IoT, by enabling the processing and analysis of data closer to the source rather than relying on cloud computing or central servers. In edge computing, data is processed and analyzed locally at the edge of the network, near the IoT devices and sensors that generate it. Today, we will find out if this is true and how it works. Let's dive right into it now. The Internet of Things, or IoT, refers to the network of physical objects, devices, and sensors connected to the Internet and can collect and exchange data with other connected devices. The IoT enables devices to communicate with each other and humans in real time and can monitor and control various systems remotely. IoT devices range from simple household appliances like smart thermostats or security cameras to complex systems like industrial machinery or autonomous vehicles. These devices typically have sensors or processors that collect data and use wireless communication technologies like Wi-Fi, Bluetooth, or cellular networks to transmit that data to other devices or the cloud. The IoT has many applications, including home automation, healthcare, transportation, energy management, and industrial automation. By connecting devices and systems, the IoT can improve efficiency, reduce costs, and create new opportunities for innovation and business growth. However, it also raises concerns about data privacy, security, and the potential for unintended consequences when devices are interconnected. What are IoT and edge computing? The Internet of Things processes connecting physical objects to the Internet. IoT refers to any system of physical devices or hardware that receives and transfers data over networks without human intervention. A typical IoT system continuously sends, acquires, and analyzes data in a feedback loop. Human or artificial intelligence and main-interpret learning (AI/ML) can be analyzed in near real time or over extended periods. If something is referred to as intelligent, that generally implies IoT. Consider self-driving cars, smart homes, smart watches, virtual and augmented reality, and industrial IoT, for example. Edge computing occurs at or near the user's physical location or the data source. By placing computer services closer to these locations, users benefit from faster, more reliable services with better user experiences. In contrast, companies help by better supporting latency-sensitive applications, identifying trends, and offer better products and services. Edge computing is one way a company can use and distribute a shared pool of resources across many locations to help scale centralized infrastructure to meet the needs of increasing numbers of devices and data. What's the difference between an IoT device and an edge device? Edge devices are physical hardware located in remote locations at the edge of the network with enough memory, processing power, and computing resources to collect data, process that data, and execute it in almost real time with little help from other parts of the network. An IoT device is a physical object connected to the Internet and is the data source, and an edge device is where the data is collected and processed. Edge devices can be considered part of the IoT when the object has enough storage and computing to make low-latency decisions and process data in milliseconds. The terms IoT device and edge device are sometimes used interchangeably. Edge computing is essential for several reasons. First, it reduces latency by processing data in real time, allowing fast response to events or alerts. This is particularly important for applications like autonomous vehicles or industrial automation, where milliseconds can make a significant difference. Second, it reduces the amount of data that needs to be transmitted to the cloud or central server, which reduces network congestion and saves on bandwidth costs. Finally, it can improve privacy and security by keeping sensitive data within the local network. Edge computing benefits IoT applications in remote or harsh environments where internet connectivity may be limited, unreliable, or expensive. Edge devices can operate autonomously in these scenarios with local processing and decision-making capabilities. Examples of edge computing in the IoT include smart cities, where edge devices like sensors and cameras can be used for real-time traffic monitoring or environmental sensing, and in industrial applications like predictive maintenance, where edge devices can monitor equipment health and alert maintenance teams when repairs are needed. In summary, edge computing is an essential component of the IoT ecosystem, enabling faster, more efficient, and more secure data processing at the network's edge, where it is generated. How are IoT and edge related? IoT benefits from computer power closer to where a physical device or data source exists. For the data produced by the IoT devices to react faster or mitigate issues, it must be analyzed at the edge rather than traveling back to a main site before that analysis can occur. Edge computing is a local source of processing and storage for data and computing needs. Here are some of the benefits of using IoT and edge together. Reduced latency of communication between IoT devices and central IT networks. Faster response times and increased operational efficiency. Improved network bandwidth. Continued systems operation offline when a network connection is lost. Local data processing, aggregation, and rapid decision-making via analytics algorithms and machine learning. An IoT gateway can send data from the edge back to the cloud or centralized data center or to the edge systems to be processed locally. Use cases for IoT edge computing. As IoT implementation rises, new use cases for edge computing emerge or become viable options. Before long, edge computing could revolutionize entire industries. Industry 4.0 is one of the most promising IoT edge computing applications. Edge networks can enable manufacturers to perform predictive maintenance analysis on machines, improving response times through reduced latency and improved reliability. IoT-based tracking solutions for supply chain operations would also become more reliable. Smart cities are another use case for edge computing with significant potential. Smart cities rely on massive IoT networks to gather and process data to improve communication, drive policies, and run public services more efficiently. Analyzing all this data closer to its source would improve real-time insights and help secure these critical operations. Edge devices in smart cities could also help self-driving cars navigate. Distributed, low-latency computing would help these vehicles' AI make the complex calculations they need to make safe split-second decisions. Edge computing pushes the IoT's potential higher. As more organizations learn what edge computing in IoT is, investment in the technology will rise. The growing popularity will lead to new use cases and solutions, pushing edge computing past its remaining challenges and into widespread adoption. Edge computing can take the IoT to new heights, maximizing these networks' performance and cost efficiency, and even addressing security concerns. Disruptive technologies like actual self-driving vehicles and smart cities will follow. Edge computing and cloud computing. In a cloud computing model, computing resources and services are often centralized at large data centers. Clouds often provide a portion of the network infrastructure required to connect IoT devices to the internet. Edge devices require network connectivity to central locations for different purposes. To allow remote management, to receive automation instructions, to forward network telemetry traffic needed for analytics, and to send data information that will be lately stored in databases and analyzed to accomplish business objectives. The communication provided by a cloud device may just be the transfer of data from an edge device across a cloud and into a data center. Or, it could be the edge device sending a log of the decisions it made back to the data center for data storage, data management, data processing, or extensive data analysis. Industrial IoT, or IIoT, refers to the use of IoT in an industrial context, such as the machines in a factory. Think of the life cycle of heavy machinery used in a factory. People may stress equipment differently over time, and breakdowns are an expected part of operations. IoT sensors can be added to parts of the machinery that are most prone to breaking or overuse. The data from these sensors can be analyzed and used for predictive maintenance, reducing overall downtime. Autonomous vehicles exemplify why IoT solutions and edge computing must work together. An autonomous car driving down the road needs to collect and process real-time data about traffic, pedestrians, street signs, and stoplights, and monitor the vehicle's systems. If the vehicle needed to stop or turn quickly to avoid an accident, sending data back and forth from the car to the cloud to be processed would take too long. Edge computing brings cloud computing services to the vehicle, allowing the IoT sensors in the car to process the data locally in real time to avoid an accident. Take it to the comments section and let us know your opinion about the role of edge computing in the Internet of Things. So, this was all from today's video. Hit the bell icon for upcoming videos, and if you enjoyed this, please leave a like and subscribe.